Hi everyone, welcome again to GeoShastram. Right now we'll discuss one component system. So this is one component system. Okay, so before moving to this, I hope you all have went through the video of the phase rule where we discussed P plus F is equal to C plus 2 and P plus F is equal to C plus 1, these both conditions. So if you have not went through that video, please go through that video first, then we'll move on. You can move on to this so you will understand it clearly. Okay, so okay, uh, one thing we'll revise. P plus F is equal to C plus 2 is the condition where both temperature and pressure are variable. Okay, so and P plus F is equal to C plus 1 is the condition where either temperature or pressure is constant. Okay, either it is a isobaric condition or isothermal condition. In that, we'll consider the formula for the phase rule, that is P plus F is equal to C plus 1 to calculate the degree of freedom. Okay, so here in one component system, so here they have not given either it is isobaric or isothermal. So both here, both temperature and pressure are variable. Okay, so here you can see this is the temperature and this is the pressure. So here you all have the variety of, so here in this diagram you have the variety of chords. So if we go on the path of increasing temperature, so we have alpha chords, beta chords, we have tridymite, cristobolite and the liquid. Yes, if we are going towards the increase in pressure, we have alpha chords, beta chords, coesite and stishovite. Okay, so here we'll try to calculate the degree of freedom in few points. Okay, so first we have taken point 1. Okay, so here the pressure and temperature is variable. To calculate the degree of freedom, what we'll do, P plus F is equal to C plus 2. Yes, this is the formula we'll use to calculate the degree of freedom. So at point 1, at 1, yes, we have cohesite. Yes, so number of phases is cohesite 1. Yes, then comes C, that is component. So how many components are there? So you take any part, it is SiO2. Yes, so component will be again 1. So putting these values in this formula, so P is 1 plus F is equal to 1 plus 2. So F will be 3 minus 1, that is equal to 2. So here at 1 the degree of freedom is 2. Clear? We'll move on to the next point, that is point 2. Again the same formula. So at 2, yes, so we have two phases. One is coincide because it is the point is lying on the line which divides coincide and beta chords. So we have coincide and beta chords. So phases will be 2. Then components again, both are SiO2. So this will be 1. So putting these values in the formula, 2 plus F is equal to 1 plus 2. So F will be 1. Degree of freedom will be 1. So here the degree of freedom will be 1. Coming to point 3. Okay. So here if you see at this point, that is we can call it a triple junction. Okay. It's a triple junction of coincide, alpha chords and beta chords. So again here the phases will be free. So again in the same formula, at 3, so we have P is equal to 3 and component is again 1. So 3 plus F is equal to 1 plus 2. So F will be 0. So here the degree of freedom will be 0. Clear? So this is the one component system where the temperature and pressure and temperature both are variable. So in that condition we'll use this formula, that is P plus F is equal to C plus 2, to calculate the degree of freedom. So when we calculated the degree of freedom at point 1, so we had only one phase, so the degree of freedom will be 2. At 2 we had two phases, so the degree of freedom will be, here was 1, and at 3 at triple junction we have coincide, alpha chords and beta chords, 3 phases, so the degree of freedom we got it as 0. So that is one component system. So let's move on to the two component system.